So this lesson is a continuation of yesterday's lesson on absolute value function and how we use transformations to graph. We're going to cover three graphing problems here. So here's the first one. F of x is equal to negative absolute value of x plus 3. So our first step is always going to be the same. We're going to circle, underline, box, whatever you want to do, all the things that represent transformations. Okay? So for this negative, the negative, we're multiplying by a negative. So what transformation does that represent? It's a reflection. It's on the outside, so it's a vertical reflection. Okay? And if it's a vertical reflection or it's a vertical, it changes my y values. And the only two reflections that we can do is over the x-axis or over the y-axis. Okay? So vertical means it's going to change my y values, and a reflection over my x-axis causes my y values to change. Okay? So the 3 here, we're adding 3. Is it on the inside or the outside? If it's difficult for you to decipher, I will help by coloring in what's on the inside of my absolute value, right? So if it's inside, if it's colored or if it's highlighted, that means it's on the inside of my function. Okay, so since the 3 is on the inside, it's going to be a horizontal. And remember the big rule about horizontal, yeah? You have to go opposite your gut. We're adding. So if we're adding, what transformation do I have? Shift. So it's a horizontal shift. Now let's go opposite our gut. So we see a plus 3. So you think it's going to grow by 3, so you're going to move it to the right 3. But opposite means going to go to the left 3 units. Okay? So there's my description of all the transformations that's occurring on this. So when we are graphing, we're going to start with my parent function, okay? Which would be looking like this, okay? And please refer to yesterday's lesson if you don't know how I got those points. All right? All right, so here is my parent function, and I'm going to label it as well. And because I'm going to color coordinate this, I'm going to label it here. Okay? So just making it neater. If you're working with one color, which is totally fine, label it here. Okay? If you're just using pencil or one type of color, label it right on the graph. Okay, and this parent function of y equals absolute value of x is being transformed by a reflection, right? So if we're just representing my reflection, it's going to be y equals negative absolute value of x. Okay? And this reflection is a reflection over my x-axis. So this point stays at this point. This point here goes 1 unit, so it goes right there. This point 1, 2 over my x-axis. So go to the same direction. This point becomes 1, so 1. And this point, 1, 2, 1, 2. Does that make sense? So here are all my reflected points, right? With my vertex being the center. Okay? So there, 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 and there. Notice that I reflected first before I shifted. That was on purpose, class. Yeah? Because the big rule about graphing, and when we have multiple transformations, we must shift last. Okay, we must shift it last. Okay. And the reason behind that, shifting it last, is because of that vertex. Whenever we stretch things out or compress things, I don't care if it's vertical or horizontal, or we reflect it, I don't care if it's over the x-axis or over the y-axis, my vertex stays put. That point right there, 0, 0, stays put, right? So the only thing that changes my vertex is a shift. And once I move that vertex around, right, and it's not 0, 0 anymore, it's more difficult for you to stretch it without making any mistakes or reflecting it without making any mistakes. Okay? So we're going to leave the vertex as is at 0, 0, stretch it, reflect it before we shift it. So we're always going to shift last. Okay? So the blue is a horizontal shift by or to the left 3. So the blue is going to be equal to negative absolute value of x plus 3. And we're going to move it over to the left 3 units, right? So if I move this point, my vertex over 1, 2, 3, there's my point. Moving this point, 1, 2, 3, there's my point. 1, 2, 3, there's my point. 1, 2, 3, here's my point. And 1, 2, 3, here's my point. So your graph will look something like that. Okay? So my graph would look like that. Cool? Yeah. That is graphing an absolute value function, right, with transformations. Okay? So we can either do this via graphs like this, or we can do this using the points. So my first parent function is y equals absolute value of x. And my parent points, we talked about it yesterday. So if you don't know the parent points, please refer to that video. Will always be -2, -1, 0, 1, 2. And this will be +2, +1, 0, 1, 2. Okay? Now this is being transformed to y equals negative absolute value of x, right? We already described it as a reflection over my x-axis. So if it's a reflection over my x-axis, what changes? My x values or my y values? My y values would change, correct? So I'm going to get my x values and literally copy, paste. Yeah. my X values do not change. Okay, so I'm gonna copy and paste this. So my Y values, they do change. And if we're reflecting it over the X-axis, or if it's multiplying it by a negative, all we're gonna do is change the signs. So positive 2 becomes a negative 2, positive 1 becomes a negative 1, 0 becomes a 0, negative 1 becomes a negative 1, positive 2 becomes a positive 2. Okay? Oh, sorry, negative 2. Yeah. So the next transformation we're doing is y equals negative absolute value of x plus 3, right? So if it's plus 3, what changes? My x or my y? My x values, correct? So I'm going to copy and paste my y values because they don't change. But I'm going to copy and paste this column, class. Okay, I'm never going to go back to the trend or to my parent function anymore. Okay, so copy and paste my y column. So that would be negative 2, negative 1, 0, 1, 2, negative 1, and negative 2, right? And I'm moving it over to the left 3 units, correct? So what does that do to my graph? Or what does that do to my points? Minus 3. So negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. Okay? And all of these points, class, align with those points up there. Okay? Cool? So that's the way we graph things. Okay? So my next example is this. Negative 2 absolute value of x plus 1. So my first step will be to circle, box, underline every transformation that we have, right? And so here, we have the negative. What does the negative do to my function? What? It's a reflection. Is it on the inside or the outside? It's on the outside, so it affects my y-axis, my y-coordinates. So it's going to be over my x-axis or my y-axis. X-axis always, right? If it affects my y's, it's going to be over the x-axis. Okay? Okay? The 2. What does the 2 do? 2 is on the outside and we're multiplying, right? Analyze that, right, from last week, correct? The 2 is being multiplied and it's on the outside. So if it's on the outside, we know it's vertical, correct? If it's on the inside, it's horizontal. And again, if you cannot decipher which one it is, color in the absolute value, right? And you know now if it's whatever's on the inside with my absolute value, it's on the inside. Whatever is on the outside is on the outside. So that's outside, so that's vertical, right? Vertical. So if it's vertical, we're gonna go with our gut. Okay? We're gonna go with our gut. Whatever our gut says, that's correct. Okay? If we're multiplying it by 2, is it a stretch or a compress? It's a stretch, correct? And if you're ever confused, multiply 2 to your bank account. Are we growing our money or are we shrinking our money? We're growing it, so we're stretching it. If we're shrinking it, we're compressing it. Okay? So it's a vertical stretch because we go with our gut. VAFO by a factor of 2. Correct? Yeah. And then the plus 1 is on the outside, right? We're adding. So it's we're adding and it's on the outside. What does that tell me? It's a vertical shift. Right? And since it's vertical, we're going to go with our gut. So if we're adding, are we shifting this up or down? Up 1 unit. Right? Okay. Questions on this? No? We got the description down, correct? Description downloaded. So we have the descriptions of this. And remember, we're going to shift last. Okay? We're always going to shift last. Okay, so in this case, class, I am going to do the points first. Okay? So I want to give you a different perspective. So y equals absolute value of x is my parent function. My parent points will never change for an absolute value function. So x, y, that would be -2, -1, 0, 1, 2. And this would be a 2, 1, 0, 1, 2, right? Those parent points will never change. The parent graph will never change. Okay, so if I go ahead and graph it step by step, it would look like this. Yeah, that would be my parent function. Okay. And then my first is a reflection over the x-axis. So then this would transform to y equals negative absolute value of x. Just representing that transformation. Okay? And again, if I have a negative on the outside, does it affect my x or my y? My y's. So I'm going to copy and paste my x's. Because I know that's not going to get affected, right? -2, -1, 0, 1, 2. And so how are my y's being affected? They become negative, right? Or take the sign, take the opposite sign. Or we're going to multiply it by -1. So the 2 becomes -2, 1 becomes -1, 0 becomes 0, 1 becomes -1, 2 becomes -2. Right? And literally plot these points. -2, 2, -1, -1, -2, -2, -1, -1, 0, 0, 1, -1, 2, -2. That's my function. That's my graph. Okay? All right? Make sense? Yes.
Go back to the I equals -9.
Okay. And my next transformation is a vertical stretch by a factor of 2. So this is going to be y equals -2 absolute value of x. Okay? So if it's a vertical stretch by a factor of 2, what's going on? Nope. Multiply my y's or my x's. my y value, right? So my y value changes. So copy, paste my x values, right? My y value is going to be multiplied by 2. So negative 2 times negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 0 times 2 is still 0. Negative 1 times 2. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. Yeah. And literally, we're going to plot these points. Okay. Negative 2, negative 4, negative 1, negative 2. Negative 2, negative 4, negative 1, negative 2. 0, 0. Next 2 points, negative 1, 2, and 2, 4. 2, negative 4. Positive 1, negative 2, positive 2, negative 4. So here is my function. Okay? All right? So we got that. Questions? Yes.
Why did you multiply the negative 2 by the negative 2?
I multiply from the purple to the blue on the blue one.
Yeah, why?
Because we already dealt with the negative. Yeah, that's why, class, we already dealt with the negative here with the purple, right? That's why I just multiplied this by 2. Yeah. And class, notice that I took the y values from my transformed graph. Okay, and again, once we transform it, we're never going back to the parent function. Okay, once we transform it, we're always going to build from our transformed one. Okay, right? And my last one, I believe, is a vertical shift up 1, right? So this equation is y equals negative 2 absolute value of x plus 1. So the only thing that's different here from the blue one is the plus 1, right? So what does the plus 1 do? Shift up 1, right? So is it going to affect my x's or my y? My y. So my x's are literally, again, going to be copy and paste. Okay, so let me copy and paste that really quick. X, negative 2, negative 1, 0, 1, 2. And my y values, if it's plus 1 on the outside, it's a shift up 1, right? So what are we going to do with my y values? We're going to add 1. Yeah? So from the negative 4 plus 1 is negative 3. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 2, negative 2 plus 1, negative 1. Negative 4 plus 1, negative 3. Right? And literally copy these points and graph these points, I mean. Okay? So if we graph the points, they're going to look like that. Okay? And I didn't label anything because my labeling are all here. Okay, but you would label the points. Okay, the graph. All right. Questions on this? Now this is your turn. Okay. So why don't you guys go ahead and try and graph that out? All right. And we will be right back. Okay, so for this one, there are 4 separate transformations, and we're gonna circle them. The negative does something, the 3 does something, the 4 does something, and the -2 does something, right? So there's 4 different transformations. Again, the negative is a reflection over x-axis, right? The 3 is going to be a vertical stretch, BAFO, by a factor of 3. The 4 is on the inside, and if you can't decipher if it's on the inside or the outside, go ahead and highlight what's inside. Okay, and if you highlight it to 4, awesome. That means that it's horizontal because it's on the inside. Shift. And if it's horizontal, we have to go opposite our gut. So +4, you think it's going to move to the right 4. But opposite our gut is left 4. And then the -2 is on the outside, so it's vertical. Shift. Down 2. And since it's vertical, we go with our gut, right? So if it's -2, it's going to be down 2. Okay? So those are my transformations. And here, I'm just going to graph it. Okay? So I'm going to start off with my parent function. All right? And by now, your parent function should be simple to do, right? So the black is y equals absolute value of x. In purple, it's going to be y equals negative absolute value of x. And remember, when we reflect it over the x-axis, right? This point here, 1, 2. This point stays the same. This point here, 1, 2. So 1, 2. This point here, 1. So 1. This point here, 1, 2. So 1, 2. Right? So all of my points are going to be here. That's a reflection. Right? Okay. That's gonna be that. And then the vertical stretch by a factor of 3, the big one, the blue one, I mean, gonna be y equals -3 absolute value of x, right? So that means my y values are being multiplied by 3. Okay? So that point at -1, this line at -2, -1 times 3 is going to be at -3. So this point becomes here at -3. This point becomes here at -3. My vertex stays the same. -2 times 3 is -6. So we have -2, -6, which is here. And then we have 2, -6, which is here. So here is my transformed, stretched out graph, right? Questions? No? And in red, I'm gonna move it over to the left 4 units. So this one is gonna be y equals -3, absolute value of x plus 4. Absolute value, right? So I'm gonna literally move this over 1, 2, 3, 4 to that point. Okay. I'm gonna move all of my points over 4 units. Okay. All right, so that's my graph there. Okay. And then the last transformation, we have a -2, a vertical shift down 2. So this would be y equals -3, absolute value of x plus 4 minus 2, right? So all we're gonna do is just move every point down 2 units, down 2 units, down 2 units. And class, if you guys ran out of paper, right, you guys don't have to do the last pair. Okay, just these 3 are fine. Okay. But if you want to, it's gonna look a little off, right? But it'll look something like that. It looks a little off here because of the little space that I have between the graph paper. Yeah, I'm talking about this space right here. Oops. I'm talking about this space right here. Yeah, it gives a little bit of space. Okay. But that is the lesson for today, class. Okay. And tomorrow's class, we're going to do horizontal shifts or horizontal stretches and compressive. Okay. Thank you very much.